Good morning, guys, and welcome to today's video where we are doing another standalone lesson on modulus functions. Right, guys, this video is aimed at roughly AS-A2 level maths slash GCSE additional slash further maths. Okay, so it's more for A-level maths, okay, so AS level maths for year 12 students and also year 13, as well, doing A-level maths. Right, guys, this video was recorded on Monday, the 30th of November, 2020. Right, guys, if you're new to my channel, welcome. My name is Abdallah Wahishi, and I'm a recently qualified maths teacher for secondary and primary. I'm currently doing walkthrough videos to GCSE, AQA, EdXL, and OCR for the past paper walkthrough solutions. Okay, I am also a online private maths tutor. Okay, for any level of maths for Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths and further maths, and I can also teach some undergraduate level degree maths, okay, for all universities. Okay, if you found this useful, please drop the video a like, press the bell icon, subscribe to my channel, and also, feel free to obviously share my videos around with anyone that might find it useful. Okay, but without further ado, guys, let's just get straight into the video today. Right, okay, so these are our objectives for today's lesson. To understand what is meant by the word modulus, okay, to understand and interpret what modulus graphs look like. Okay, so again, A-level maths, AS slash A2 level maths, okay, for, A-level math. Okay, right, guys, y equals modulus of x. The word modulus means the positive amount, so it's the positive amount of that number or function, okay, so it's the positive amount. Okay, so for example, like y equals the modulus of x. Well, y equals x here looks something like this. So it's got a gradient of 1, and it passes through the origin 0, 0. Okay, so this is a line y equals x. Okay, now the modulus is saying is, so for all y values, okay, so for all x values, y must be positive. Okay, so modulus of x in this case means that y, all of y values, so all y values, must be positive. Okay, so what this means is, okay, that for any value of x, y must be positive. Okay, so that is the context of this of this topic for today's lesson. So for all values of x, okay, so the modulus, so all this has to be positive. So it looks something like this. So for all values of x, whether it's positive or negative, y must be positive, because that is what the definition of modulus function means. It is the positive amount of that function. So it's the positive y values for all the range of positive and x values for negative and positive. Okay, so I hope that actually makes sense so far. Okay, so modulus just means the positive amount, okay, of a number or a function. Okay. Next one, y equals the modulus of x plus 2. Okay, so x plus 2 plotted looks like this. So that is currently the graph y equals x plus 2. So a gradient of, I think I've made a mistake here, sorry. It should be like that, sorry, not like that. Okay, so it goes through 0, 2, and it's got a gradient of 1. Okay, so that's actually mistaken, which means that that's also going to be mistaken as well. So drawing this again, okay, so again, looking at our graph here, guys, okay, so looking at this graph here, okay, so it has to be positive, so it looks something like this, like that, okay, so it's not actually drawn perfectly, but yeah, so the idea is that it can't be like, like negative values for y, so y must be positive for all values, so it crosses at 0, 2, and minus 2, 0. Okay, So that is a graph y equals modulus of x plus 2, guys. Okay, if you're not very confident with how to plot straight line graphs, then check out my video that I made back in February, March this year. I think it was in March this year, with how to plot straight line graphs here for the form y equals mx plus c. But the idea is that we are just doing like sketches for the gradient, and then so m is my gradient, and then c is where it crosses on my y-axis. So the plus 2 means that it crosses on the plus 2 here, and then it's got a gradient of +1. Obviously, I haven't actually plotted it properly, but that is like a rough sketch of my graph. Right, guys, example number 3. Okay, so y equals the modulus of x minus 5. Okay, so this time this is correct. So y equals x minus 5 crosses the y-axis to -5, and it crosses the x-axis at 5. Okay, so it's 0, -5. Sorry, not 0. 0, 5, and 5, 0. Gradient of 1, and then y-intercept of it. So remember that it's y equals mx plus c, guys. Okay, it's my straight line. M is the gradient, and then c is the y-intercept. X minus 5 looks like this, guys. Okay, so again, same graph, but there is no negative value for y, so it looks like this. So it crosses at 0, 5, and 5, 0. Okay. So that is like a way to remember it. And also, just to actually add to my previous point, that so before my point was here, my new point is going to be here now, because it is reflected essentially in the x-axis. So the negative quadrant for y is reflected in the x-axis. So that will be similar for all the other examples that I went through. Okay, so yeah. Okay, so 0 minus 5 becomes 0, 5. Okay. Right, guys, last example for today's lesson. Okay, so y equals a modulus of 5 minus 7x. Okay, so 5 minus 7x. So it crosses. So currently it crosses the y-axis like this. Okay, so it crosses at 0, 5. It's got a negative gradient. Okay, so that means that the slope is going to go down. So the reflection, okay, so it crosses here at 5/7, 0. So a new graph will be reflected here. So a new graph will look like that. Zero, and then 0, 5, guys. Okay, sometimes, obviously, so for this one, the coordinates haven't actually changed, but sometimes, depending on what you plot, sorry, yeah, ignore that, guys, that was like a rough sketch of my original graph, okay, but I think I made a mistake. Sorry, no, sorry, that was correct, but I think because there was no ruler, sorry, so my my line went a bit wonky, okay, yeah. Okay, so that was actually correct, sorry, but that was just because the line was a bit wonky. Okay, so I'll put that there, yeah, to obviously solve for x. Okay, so when y is 0, x is 5/7. Okay, for the x, for the coordinate of the where it crosses on the x-axis. Okay, but going back to my point earlier, is that some points when reflected won't actually change. So this one doesn't actually change. So yeah, So yeah, it just depends on what the graph that you actually plot, okay? So guys, I hope it actually made sense. Any questions or any queries, put it in the comment section. Sorry about the sound of my voice, actually, guys. I've got a bit like a sore throat recently, so my voice is a bit crooked, so sorry about that. Apologies. Yeah, so that is lesson for today. So next standalone, guys, will be this Wednesday, which will be looking at solving modulus equations, okay, but we will do more practice, and then I will, of course, be going back to doing the OCR papers at some point as well, but I wanted just to have like a week or two of just doing like random standalone lessons. Okay, if you want me to cover any topics for GC or Key Stage 3, then obviously put it in the comment section. I'll be happy to like do like standalone lessons. Two students have actually contacted me about doing a vectors. Okay, so I'll try my best here to make a note of that and do like a vectors video at some point. Okay, but yeah, but the plan is, yeah, so this lesson will be the last standalone lesson, yeah, for the random topics that I'm picking, and then I'll be going back to the OCR papers, yeah, as well, later on this week or next week. Okay, right, guys, that's it for today's lesson. I hope it made sense. Please like, comment, share, and subscribe, and obviously spread the word about my channel. And I will see you hopefully in the next video. Okay, take care, guys. Stay safe, stay healthy, and I hope you're all doing okay this term. Okay, see you soon.